Hey. Thank you, Scott.
I know for a fact that the more you talk, the more you talk as part of the discussion, the more you will learn. So somebody raise your hand and tell me what to write on the board next. Ellie.
So UI over CX equals
No one else talk, please.
1 over square root of 2 times square root, and then 3 to the 4x, and then by the derivative of
3 for Ellie, well done. I want to talk about that stuff. Because I keep reminding you, you can't just copy what I do. If you copy what I do, your score on the test is going to be about 4 out of 33. I'm serious. Like, copying's not going to help. What you have to do is make sure you understand how did I get from one line to the next, what was the rule that I used, why is it valid, then you'll know how to apply it to the new situation. Any questions? Some of Jeff.
That's not a question.
Oh, please.
Then you gotta find the derivative of 3 to 4x.
So write all this again. Save you saying it. Tell me now what to write, Jeff.
Did you first start with functional?
In this case, you can. Good try though, because it's not 3 multiplied by 4x. It's 3 all being raised to the 4x. So 2 for Jeff, but somebody help, hopefully.
So what did you get? Exponential rule?
Exponential.
Oh, great. Which is ln of 3, and then 3 to the 4x derivative of 4x over.
Oh, great. I was confused.
Write down whatever you tell me to write down.
That's not an ln. 3 to 4x derivative of 4x over 3x.
Nicely done.
Oh, yeah. Oh, no. Yeah. Hit me.
Oh, that's oh yay, right? How do you spell yeah?
That's yeah.
Yeah.
That's yeah. Oh, yeah. Why?
Please.
Imagine the next one.
Hold on a second. 3 for Oakley.
Wait, what means?
Exponential. Exponential. I want to do the whole class on this one. Look up. Hey, look up. Raise your hand if you know what this is without me writing anything. Just show me that. Quickly. What is it, parents? How many do that? 2 for everyone. 3 for parents. Can't draw a whistle, but whatever.
Yeah. Got it.
Okay, pause for a second. Okay, no one talking, no one talking. Please.
What's the big difference between the power rule and the exponential rule?
I'll ask you a couple of things and then you'll see it pretty clearly. I don't think that's trouble anymore. So, Anna, when we're dealing with the power rule, we're looking at a function, we're finding the derivative of something, some function whose base is a variable expression. So you can make up any expression you want, just give me some sort of expression.
Like 4x.
Yeah, 4x is fine. Okay, so that's the base. And then the exponent is a fixed value, just a number. So give me a number. 2. If we are finding a derivative of something like this, that's the power rule. You okay with that? The other one, which is kind of the opposite, is now you tell me a base that's some number, 5, and now make the exponent of that base some variable expression.
Like 4x.
4x is fine. This would be the exponential rule. So this is exponential rule. The black one is the power rule. Was that your question?
Mm-hmm.
Good. So 3 for Hannah for asking. Voices.
So you do the exponential rule if it's a constant, like without the x, and then if it has the x, you do the power rule.
you've got the right idea, just clear up the language just a little bit. So we use the exponential rule if the base is just a value of some number, not any sort of variable expression. Here's some examples. 5, pi, e, 200, just some constant value. And then the exponent is where the variable expression is. Good there? Yeah. And then power is the opposite, basically.
Okay.
Does that help?
Yeah, good. Can it be like 4x to the x?
Oh, thank you. That situation we won't ever encounter in our class, where both the base and the exponent are variable. That just won't happen for us. We won't worry about it. Good question. Jackson, anybody else? Awesome. Hey, look here, please. Look. I want everyone looking here. Look at this. Okay, notice all the ones. Strongly recommend you do that. It's really easy when you start dealing with some terms are fractions, some terms are not fractions, to get mixed up as to what's in the numerator, what's in the denominator. You just put over 1, it keeps it all straight. Pretty good? You're going to ask the whole class something. This really is one big fraction because it's simply one fraction multiplied by another, another, and another. So there are 4 fractions being multiplied to create one large fraction. You're going to vote. 1 means this big large fraction, the numerator of this fraction is in factored form. That would be 1. 2 means this numerator is not in factored form. Show me your vote. 1 means the numerator of this large fraction is in factored form. 2 means the numerator is not in factored form. Show me your vote like this, please. Silent vote. If you try, I give you 1. If you're right, you get 3. If you don't try, you get 0. Is the numerator in factored form? So Amanda says yes. So Amanda, what are the factors of the numerator?
Factors of the numerator are 1, 3, and 4x.
Perfect. There are 4 different factors that are multiplying to create the numerator. So the numerator is in factored form. That's 3 tickets. 1 if you voted wrong. Question?
Yes.
And 1 extra for Amanda for being the voice. Chad,
What would it be called when it's like simplified then?
I don't know what you mean by simple.
Like if you like combine the numerators? Like 4 and 3.
You can't combine the 4 with the 3 because the 3 is being raised to an exponent.
Oh, well,
So those can't multiply.
4 and the 1 then.
If you multiply the 1 times 4 is just 4. So
Go with that.
don't worry about it.
I missed
We
it.
kind of
Like,
stalled
why
out
did-
on that question.
Why did you put them over 1?
Oh, I don't want to get mixed up, and I want to make sure I know that this is the denominator of a fraction, and this is the numerator. And I've seen students who'll write this, and then they'll write ln of 3, and you can't tell whether it's on the top or the bottom. The 1 just keeps it straight. Cool. Hey, if the numerator is factored, that means we can look for matching factors and divide them. There's a hidden match. Look at this over here, please. I'll write it on the board here. Look, over here. 16 is exactly the same thing as the square root of 16 multiplied by the square root of 16. Like, study that. Make sure you are comfortable with this. If you're not, raise your hand so we can talk about it. Are you comfortable with this? Okay. Does it make sense?
Yeah.
Perfect. I'm going to use that right now to do this, hopefully. At dy over dx. Oh, wait a minute. This factor of 4 in the numerator can divide with this factor of 2 in the denominator, so this will become 2 in the numerator. So we'll put the 2 over here, actually. It's a good place to put it, isn't it? So we'll put 2 divided by square root of 3 to the 4x. And here's where I'll use the newfound discovery that Oakley mentioned. Instead of writing 3 to the 4x, I'm going to write square root of 3 to the 4x multiplied by square root of 3 to the 4x. Someone is asking why, but someone else in the room knows why I did that. Raven.
Because when you multiply those two together, it'll equal to 3 to 4x.
Yeah, this isn't any different. the whole class, the most fundamental concept of everything you are learning in math from the very first day that you learned math is equality. When can we declare that two things are the same? This is exactly the same as this, just like I showed you here. Perfect. Why did I do it though? Like, what was the advantage of writing this like this? Here you go, sir.
Because I can read this one on top and one on the bottom.
Oh.
This factor can divide with this factor. And now we're done. Question? Well, we also have a different question from the practice session like to talk about. 24. Savannah, read, please.
Y equals, and then in parentheses, x plus 3. And then close parentheses.
Like that. One of the best ways to make all these memories permanent is to, in class, just raise your hand and you tell me what to write. But don't look at what you have already written. Like, just do it from your head. It's a really good way to practice with the tablet. You verbalizing the answers makes the memory more permanent. Somebody tell me what to write on the next line.
We do the x. D x plus 3 over here. Plus x plus 3. D x over D.
Yeah. 3 for Sarah. She made one glaring error. I'll pay everyone in the room who can see it. If we don't fix the error, you'll step in a trap. No worries. Raise your hand if you can see the mistake.
The glaring.
Screaming at me. Who sees the error? It's not screaming as loud as we like, but it's there. Who sees the error? Brady.
Does she need the parentheses around x plus 3 because it looks like it's plus x plus 3?
Nice. It really looks like the x is all by itself. Like the x is not associated with the derivative, and it can't. It's got to be x plus 3 times the derivative. It's perfect. 3 for Brady if you had it. Who else had it before you said it? 2 more.
What rule was that?
So the rule from here to here was the product rule. And we simply needed the parentheses because the product rule requires that you take the entire first function multiplied by the derivative of the second. Without the parentheses, we're not multiplying x by anything. Does that make sense, Kelsey?
Yeah.
Good. Please.
Yeah, I think, so that's one big function on the top, and that's why you use the product rule, correct?
We use the product rule because we noticed in the first step, we're trying to find ddx of one function multiplied by another function. 2 functions being multiplied to find the derivative. Step number 1 is the product rule.
Okay. So if they're separated, like, let's say that x plus 3 is over e to the dx, then you wouldn't use the product rule, right?
Tell me exactly what to write.
So x plus 3.
You already x plus 3?
Yeah, x plus 3 parentheses. Over e to the dx.
Like this?
Yeah.
You
So
have
let's just say you have something like that.
Yeah.
Then
You'd have to
you-
use the quotient.
Cool. I think I just get mixed up.
Don't you?
Yeah.
Do you use the quotient?
This would be the quotient rule.
I need to memorize that one.
These memorize all of them.
Yeah. I said the others. That's one of the other ones I need.
I knew what you meant, but I just couldn't resist.
Okay.
Please.
You just got rid of it. Marginally. Take that one.
dx equals and then open parentheses,
Oh, pause for a second. You're doing fine. Hey, look up. Whole room. Raise your hand if you know what this is without me writing anything down. I'm just trying to get a little faster at this. Know what this is without writing anything down. Okay, everyone knows. Let's go, Deborah. Deborah says 1. How many agree? 3 for Deborah, 2 for the rest. Keep going over.
Okay, and then you're gonna have x plus 3, and then just
Wait.
x. Is that it?
So,
Yeah, that's it.
Parentheses.
Brady,
He needs the parentheses again.
get the
You
parentheses.
brown
You're gonna
noser.
step in a trap, I promise. Like what you'll do is you'll keep going and you'll find your answer. It just won't be the right answer. Don't forget the parentheses. It's all right.
Wait.
Chad, please.
So on the second, e to the, or d to e to the x. So the e to the x just comes down. What rule is that?
So the rule he used was the E rule.
Oh yeah. And then
Here are the details. The derivative of e to the something is simply e to the something, derivative of that something. That's all. Is that your question? Someone else know what we write? Jeff?
Okay, so you list out factors.
Would be good, sure.
So, but you can, so I'll just do it. So e to the x on the outside, just take out e to the, and then you should just be left with x plus 3.
Like this?
Yes.
Everyone look at the board. Hey, I'm gonna give Jeff 4 tickets for being a good sport. Look at the board. This is a trap. This is the wrong answer, but it will be one of the possible answers. So what's the mistake? I'll know the mistake he makes. Everyone will know. Okay, everyone knows the mistake he made. What's the mistake he made right here? What's the mistake? Let's go, Amanda.
On the left side of the
Yeah, you forgot this factor right here. So when we factor the e to the x from this expression, there is still a 1 remaining. This 1 remains, and then the x plus 3. And no, perfect, hopefully. Now, please remember, at this point though, there's only a positive 1 here, positive 1 here, positive 1 here. So all those positive 1s have no effect on the x plus 3. So that can be rewritten to what's really inside the parentheses?
X plus 4.
X plus 4. That's the correct answer.
I knew that.
It's combining like.
Yeah, I do.
Yeah, you're just combining like terms. You're just adding what can be added. Cool.
And just undo the parentheses.
I've got one.
Okay, pause for a second. Anyone else have a question here? What number was that?
Instant card.
It looks like 2 suddenly magically became 1. That's not really what happened, although I know why you're thinking that. What we did is we used the distributive property in reverse. For example, help me, Amanda, if I want to distribute, I would take this times this would be x plus this times this would be. So now we're back to what appears to be 2 different values of these. They're the same thing, you're just writing it in a different way. Yeah, please, Coach.
How does that equal 1 from like the second, the last one stuff that you have?
From here to there.
Yeah, how does it
Where does the 1 come from?
Yeah.
Okay, again, okay, all of you are really good at this. Like I need everyone to look at the board, please. Or you really will step in many, many traps. Like you gotta straighten this out. You're all really good at this idea. If I write 2, and then I say x plus 3, right? What's that the same as? Tell me. You're comfortable with that, right? Like you feel no discomfort with that, right? Okay. All we're doing is we're using this concept, but instead of going this direction, we're going this direction. So here we have this and this. When we factor, we identify the factors. E to the x and 1, x plus 3 and e to the x. We pull out the common factor of e to the x. There's still a factor of 1 that remains. It has to be there because if we do this, and we multiply it out, Kelsey, what's e to the x times 1? E to the x. What's e to the x times x plus 3? Times x plus 3. Is this the same as this?
But how did you get from the step before that?
Oh,
x
here.
plus 3 to 1?
So
Like, how
from
did
here
you-
to here?
Yeah.
Oh, different question. No worries. Are you okay with the part I showed?
Yeah, yeah.
Okay, good. This one here would look like this. You use the add subtract property first. What's this equal to? What's this equal to? Like distribute this one here. You can. I would learn to do the way we did it. It helps prepare you for some future problems where you've got to be able to kind of easily deal with your parentheses. So I would do it. Good question. You're good. Read for me.
So should I do it when it's,
Just look at very good.
okay, right?
There we go.
1 divided by square root of x.
What?
Okay, time for silence. You want to talk? Everyone look up. Someone raise your hand and start speaking. Trevor, please.
So you need the equation R. And so it's gonna be the square root of x, d1 over dx minus 1, d through x divided by dx over square root of x.
You take it for Deborah. Perfect. No question? Landon?
The square root on the bottom just cancels, so it's just over x, since it's squared.
Either way, I'm going to leave it as, I do this out of habit quite a bit actually on a quotient rule problem. I'll leave this alone. I won't square it because a lot of quotient rule problems, it becomes easier to kind of combine terms and things if we just leave it like this. But it definitely becomes x. It's the same thing. Anybody else? Please.
So d1 of x just becomes 0. So then negative, the square root of x is 0 plus 0, right?
So this is 0.
So then it could just be, would it just be, I don't know how to write that. Oh, it's the square root rule, correct? I'm taking it. So then we're gonna have it be, 1 over 2 square root of x in parentheses.
This part doesn't have to have parentheses because there's nothing being added. That's fine.
And then dx
There we go.
all over the square root of x squared.
2 broke me. Hey, Landon, for example, I've got a root x here and a root x here, so leaving this as root x is going to make it maybe perhaps a little easier to see how those combine. That's all. Please.
What does the 2 come from?
Simply the square root rule. The square root rule says that the derivative of the square root of something is equal to 2 times the square root of the something. You can see it, Heidi?
Yeah.
Good. Please.
And then so the square root of x on the first one, do I have dx? Sorry, I'm not answering.
You're good. Keep going.
So because d1 over dx equals 0, then you just times 0 to square root of x, right?
Uh-huh.
Okay, that's
perfect. No, you're good.
Okay, good.
This is 0. 0 times root x is simply 0. Perfect. Heather. You're good.
So, why is d1 over dx 0, but like the problem we did before, d3 over dx is 1, so...
No, look back for a second. Good question, Heather. This right here, we split it up using the addition property. So dx over dx plus d3 over dx. The d3 was 0.
Okay.
Yeah, the derivative of any constant is 0. It's a good question, though. There we go. So, someone else got one. Let me show you. This is something that hasn't happened too much this year. Although it's not a new concept, it's something you learned in like 5th grade. You just forget. Look, all we have is one fraction on the top and another fraction on the bottom. If we write them both as fractions, it makes it a little easier to see. So this is really the square root of x squared divided by 1. Whenever you have a fraction divided by a fraction, as I said to Braden a minute ago, it's all about equality. You've got to make sure everything is equal to everything else. So this is the same as the top fraction multiplied by the reciprocal of the bottom. That's not a new thing. You did that in 6th grade over and over again. It's simply how fractions are divided. One fraction divided by another means we multiply by the divisor's reciprocal. Questions? Awesome. Okay, this is why I left it as root x, because now then what I have is a root x times a root x times a root x, which means I have 3 of them, or a root x cubed. So I have the I think the answer looked like this.
-1.
Oh, thank you. I think the answer looked like this. They put the cube on the x inside. Either one, it's the same thing. So, please.
So if you factored out the square root of x squared in the beginning, would it change your answer?
So what I would have seen would be this, Braden. Let's just back up. So let's say that right here, I instead start writing this. -1 over 2 square roots of x, all over just x, like that, right? Yeah. And then the next line would be, we would multiply by the reciprocal. So at that point, I'd probably write it like this. I'd say -1 all over 2 times x times the root of x.
Would that be the same answer as?
This is exactly the same answer as this. It's not the multiple choice answer, so then I would have to remember the Oakley discovery that root x is the same thing as square root of x times square root of x. And that would lead me to find the correct multiple choice answer. Please, Heidi. Huh? You let's have a follow-up here. Read 5 for me, Heidi.
It says y equals 5 minus x divided by 5 plus x.
Okay, somebody was right. Please, Lynn.
So you would just do Lodi high minus Heidi low, which would just equal what? 5 plus x. D parenthesis 5 minus x over dx minus 5 minus x, parenthesis 5 minus x, and then d parenthesis 5 plus x over dx. all over 5 plus x squared.
Right.
One glaring error on the board, you see the one big trap just waiting to spring. You see the trap sort?
Is it the 5 plus x if you're getting these in parentheses?
Yeah, it has to be.
thought about
3 for
that.
Soren, 2 if you knew it as well.
I thought about it. I'm not sure about it.
Somebody, oh, we can do the whole class for a second. Raise your hand if you know what this is going to become without writing anything down. Just raise your hand if you know what that's going to be. I'll play you. So I'm going to turn out to be, let's go Alyssa. Alyssa says -1. How many agree? 2, 3 for Alyssa. How about this one, please? Another chance for some quick points. What's this going to be? Oh, no. Lexi? How many agree with Lexi? 2, 3 for Lexi. So somebody tell me what to write on the next line. Go, let's just trade off here for a second. Let's go, Ellie.
-1 parentheses 5 plus x, and parentheses minus parentheses 5 minus x, all over parentheses 5 plus x.
Perfect. Questions from anyone? Perfect. Jackson?
What about the plus 1? Plus 1.
Oh, this became 1, right?
Yeah. Yes, but wouldn't it be plus 1 because it's 0 plus 1?
Oh, sorry. You're thinking correctly. Let me just, hold on. Here's what, you're thinking very correctly. You're making one tiny mistake. So this becomes 0 plus 1, but what is 0 plus 1? 1. So it's really just 1, and then 1 times this would just be this.
Okay.
Does that make sense?
Yeah.
Good question. Anybody else? Somebody tell me what to write on the next line. So Sarah.
-5 minus x minus 5 minus
3 for Sarah, she made a crucial mistake. It'll lead to a trap answer. Very crucial mistake. You can see it whole class. Like everyone find her mistake. She found it. Everyone find her mistake. Yeah, it'll lead to a trap. Like you'll think you have the right answer, you'll circle it, and you'll never know until you get a sketch of that. You can see her trap. Parents? Say it louder. Should have been plus x. The -1 times 5 would be -5. The -1 times -x would have been positive.
That's what's not
How many saw? How many saw? 2, 3 for parents. Questions?
Oh, because the two people need.
And Sarah saw it as well, right, Sarah? Please check.
And so the reason you couldn't, it's like there's a 5 plus x on the top and on the bottom, but the reason you couldn't like take one of them out is because it's not being multiplied by each side. Does that make sense?
It's because the top is not in factored form.
Yeah.
The top, just memorize that phrase, it really will help. The top must be in factored form.
Okay.
People say all kinds of things. They'll say things like, oh, it's because there's a plus in the top. It's not because there's a plus in the top. It's because the top is not factored. Okay. Anybody else? Somebody tell me what to write next. Jeff.
I saw it. You say you combine like terms, they combine like terms on top, just end up there, and then over side plus x.
Please don't. I think so. You have a follow-up question? Oh, please, please.
So when do you know when it's like in factored form?
Got it. What we really should do, Chad, is, let's flip the board over for a second. We really should just keep doing example after example after example of factored form, not, until everyone is really comfortable with what I mean by factored form. So, factored form means you can view the numerator as several terms or expressions being multiplied together.
Okay.
So, give me an expression.
Like x
X is good. Give me another expression.
5 plus 5.
So that would be considered one expression.
Yeah.
Give me another expression.
Why? I don't know.
Sure. Okay, there's a numerator. Think of it as over something. That numerator is not in factored form because you cannot tell me that that numerator consists of 2 things being multiplied, or 3 things being multiplied, or 4 things being multiplied. It's not in factored form. The only way to view that numerator as factored form is to say that numerator has one factor. And the one factor of the numerator is x plus 5y. That's the only way I can view that as being factored. So if there were an x here in the denominator, I would not be allowed to divide this x with this x because they're not factors. The x in the bottom is a factor of the denominator. The x in the top is not a factor of the numerator. That kind of makes sense?
Yeah.
Good. Let's do another one. Somebody else. I got 3 for that. Just have to give me some sort of expression. I don't care. Just make up anything, read something off a problem. Ellen.
X plus 2 multiplied by 4x plus 8.
Okay, let's check the full room. 1 means that you believe the numerator is in factored form. 2 means you believe the numerator is not in factored form. Show me your secret vote.
Wait, 2 is?
So 1 means the numerator is in factored form. 2 means no, the numerator is not. So show me your vote. 1 means the numerator is in factored form. 2 means the numerator is not in factored form. If the numerator is in factored form, you have to be able to tell me, I see the numerator as this times this times this times this. If you can't identify the several terms that multiply to create the numerator, then the correct answer is 2. The numerator is not in factored form. So show me 1 or 2. Is factored form, is not. So most are getting it, some still not quite. It's not in factored form. These 2 terms are being multiplied, but the entire numerator is not a series of terms being multiplied. It's really, these 2 are being multiplied, then we add a negative 10x. So it's not strictly several terms being multiplied. Please.
So like, let's just say the minus 10x is in parentheses. Would that make it a factor?
Perfect. So if I have this, now I can tell you that the numerator consists of this factor multiplied by this factor multiplied by this factor.
And then, like, I don't know if this is a general rule that won't work, but so like if there is any minuses, like, or addition or subtraction, but it's not part of it, I don't know how to say it exactly.
Honestly, I've struggled with exactly what you're struggling with for a long, long time.
Yeah.
Like I've tried to think of every possible situation I've ever encountered, and the only phrase I have found to be consistent is the phrase I always tell you, which is the numerator must be in factored form, meaning I have to see something multiplied by something multiplied by something. It's not a matter of pluses or minuses or parentheses. It's just I've got to have something times something times something. For example, here's another one. You know, like for example, if people rely too much on the plus idea, they'll say, oh, this isn't in factored form.
Yeah.
But it is. Here's one that doesn't have any parentheses. Vote. 1 means the numerator is in factored form. 2 means the numerator is not in factored form. If you vote right, you get 3 tickets. If you vote wrong, you get 1. If you don't try, you don't get any. So 1 is correct. The numerator is in factored form. Someone gain 3 more tickets and tell me what are the factors of this numerator.
2x and sine 2x.
Perfect. Either the 2x is a factor of the numerator, sine of 2x is a factor of the numerator. Oakley, are there any factors in the numerator which match factors in the denominator? No, so this is not legal because they're not matching factors. 2x is not a factor of the numerator. That's why I teased you at the very beginning of the year, right? Cancel's the worst thing ever that was ever mentioned because people think that, oh, the way I do math is I get out my ruler and I draw lines through things. No, it's nothing to do with drawing lines. So We understand? Questions? Chad, does that help?
Yeah.
Good. Somebody had another question. Oh,
Yeah, I just wanna go over number 20.
sure, read it to me.
So, 20 says y equals 4 to the x over x to the fifth. And that's it.
Pretty good. Many test questions. The one I like best, since I wrote the test, the questions I feel like are most clever are ones that really don't look complicated at all, but they require knowledge of several different things to be successful. I like this one for that reason. Just you got to use lots of different rules. You got to remember factoring, et cetera, et cetera. And it starts simple and ends up pretty simple. So, someone, let's see. We start with this. Someone tell me what's right. Please do.
Continue back to the 5. For the x over dx minus 4 dx dx to 5 or over d to the x over all over x to
Better to leave it honestly as x to the fifth squared. It is x to the 10th, but it's just better. Somebody else? Somebody tell me what to write on the next line. Guys, hold on a second. If I don't say tickets, make sure you always give yourself 2. So.
And then Ellen, or I put parentheses for that.
It doesn't hurt anything. Perfect.
For, and then for the x over dx.
2 for Sarah. Somebody else? Please.
4 to the x, and then 5x.
2 for Ellie. Question? Keep going. Somebody else? Yeah, this isn't. There's no multiple choice answer. It looks like that, so we gotta do something more. Deborah.
You can take out, x to the 4 and
2 for Deborah. Deborah's going to factor x to the 4th and 4 to the x from both of these two expressions. So someone tell me when x to the 4th and 4 to the x is factored from this expression, what are the remaining factors? Hopefully.
So the d is x, and then ln of 4, and then minus, minus 1, wait, no.
One's
Yeah,
okay.
Yeah, minus 1, and then just be 5.
Good.
Minus 5.
And so 1 times 5 being 5, we can just say minus 5.
Yeah.
That's perfect.
Wait.
Hold on one second. You're good. Talk to me, Soren. I can see it's still not clicked. It's fine.
Yeah, wait, where's the x to the 4?
No worries.
In like the,
first part.
yeah.
Yeah, let me ask you, you'll see it better.
Okay.
So here's an expression.
Yeah.
Okay, first of all, the entire, we just got done talking with Chad. The entire numerator is not factored because we
Right.
cannot express the numerator as something times something good. Okay, but we can look at this expression alone and identify something times something.
Yeah.
So Soren, what are the factors of this expression?
X to the 5th.
Good. Now here's the key thing. X to the 5th really means x multiplied by x 5 times.
Right.
You with me?
Yes.
What other factors do you see here?
Ln of 4.
Perfect.
And then 4 to the x.
Perfect, and then the one that's always there. Good. What are the factors here, Soren?
4 to the x, then 5x to the 4.
Keep 5 separate, it's better.
Okay,
So it's
5.
5 multiplied by 4 of these. You with me? Good. So now, what factors are present in both expressions?
So the 4 to the x,
4 to the x, that's right here.
and then x to the 4th, which just leaves one of the x.
Right.
on the y.
Did that make sense?
Yeah.
That's what you were thinking, is that correct?
Yeah.
Good. Anybody else? That was well done, Sloan.
Could you take the x of the 5th on the top and then, I can't remember the word for this, but take out one of the ones in the bottom?
In this case or in this case?
The top, the
This one here?
first case, yeah.
So I'll ask you the question, is the numerator in factored form in
Oh
this
yeah,
case?
no. it's
Nope,
not.
so you can't.
Yeah.
Good question. What can we do now, though?
There's 4 x's on the top and 10 on the bottom.
Yeah, everyone hear that? There are 4 x's here, x times x times x times x. On the bottom, there's 10. X times x times x, blah. So those do divide because x is a factor of the numerator 4 times, and x is a factor of the denominator 10 times. So several of those divide to make 1, and it leaves exactly what Deborah has said, which is there are no longer any x values here, and in the denominator, there are 6 that remain.
Oh,
Well done, Deborah. Please.
Are we done?
I think so. Any follow-up, Jeff, please?
sorry.
No,
Do you need?
You keep asking. Like everyone hear this. I'm serious. It's a very sincere compliment. What you do is what I need everyone to do. If something feels uncomfortable, you just talk about it.
Yeah. Well, this one it doesn't matter a ton, but do you actually need the parentheses on the top, or since there's like?
Keep talking.
Because like you said, really, like if there's like a 1 in front, like if there's ones all around it.
Are you talking about the parentheses here?
Not the
Or here?
that step, yeah.
Oh, these I have to have the parentheses. Here's why.
Uh-huh.
On this side of the parentheses, really, there's this.
Okay.
Yeah, it's really this
Right.
gets multiplied by this and by this.
Yeah.
Good question. There you go. Different problem?
Number 17.
Your next same one, Jeff.
17 or 21.
We have time for both, so we're good. Jeff, read 17.
It is y equals parentheses x to the 25th plus 3 over 5 and parentheses squared.
Correct?
Yes.
Hey, look up, please. Okay, this does not happen very often, but once in a while they will give you a problem where if you do something before you start doing calculus, it makes the calculus much easier. In this case, what I noticed right away is that the denominator is just a constant. The denominator is not some sort of expression involving x. The denominator is just a constant. If I can factor out a constant, everything else becomes easier. So what I thought to do was this, before I even begin. Squaring is easy to understand. It just means multiplying something by itself. So what I really have here, no calculus yet. This is not calculus at all. I'm just recognizing that to square something means to multiply it by itself. Is everybody good to there? Okay, if I multiply top and bottom, so I go top times top, I don't really want to expand it, I'm just going to write it like this. But the bottom is more simply written as 25. Questions to there? Now, dividing by 25 is exactly the same thing as multiplying by 1 over 25. I gotten rid of this constant, which makes the rest of the problem significantly easier. Because a multiplying constant doesn't get in the way. That's kind of a tricky problem, it is. But it's good to have seen it at least once, talk about it as much as you want. Derek, please.
Can you just, like, how you went from an over 25 then times 1 over 25? I know it's simple, can you just explain it a little?
No worries.
3 to 4, just.
From here to here?
Yeah.
Perfect, perfect. Let's do a simpler example kind of over here for a second. If I have 8 divided by 2, that's exactly the same thing as 1/2 multiplied by 8. Do you agree?
Yeah.
Yeah, that's all I did. Something divided by 25 is no different than 1 over 25 multiplied by the same thing.
Okay.
Was that your question?
Yeah.
That's a very good question. Anything else? Please.
Is it okay to dump that and do the power rule?
There's nothing wrong with starting with the power rule and just plow ahead. It works just perfectly fine. This is just an alternate way that's a little bit, I don't know, I'm not sure it's easier, it's just different. Is that fair? Good.
So you can change like the form of the equation before you start doing the derivative?
Absolutely. And I usually don't change anything unless I simply see that there's a constant that can be easily factored out. I don't really change anything else. But you can do a Paris to just start and just go. So
It's just a little harder.
it's a little bit, I'm not even sure it's harder. It's just different because you don't do all this, you do something else.
Yeah.
I can do it either way, it doesn't matter, Sora.
So, at step 4, so the 1 over 25 times x to the 10x, are you taking the derivative of all of that, or only of the x to the 25th?
Great question. I still must take the derivative of both sides. And so I have to take the derivative of everything. But the constant property of differentiation allows me to now say that the 1 over 25 multiplying constant can come out.
Okay.
So no, it's still there, and it was still part of what was being differentiated, but the constant rule makes it seem like it didn't matter. Did that answer your question, sort of?
Yes.
Everybody gets it there? So then what would be the next line? Power rule. So, is that Heidi?
Yeah.
Tell me what to write, Heidi.
Times 2, then parentheses, x gives 1
Keep going.
and then d over parentheses, x to the power of x plus 3 over dx.
Perfect, Heidi. Then I would go back and say this is really 2 over 1, so I don't lose track of whether they're numerator or denominators. Pretty good? Okay, whole room. Ratio, if you can tell me what that is without me writing anything. Just checking the room. Everyone knows gets paid. What's this going to become if I don't show any steps? So, Michelle?
25, x to the 24.
How many would have said what Mikel said, please? 2 points, 3 for Mikel. We want to see the details. So we use the add subtract rule first. If you're okay with there. Then I use the power rule here. The derivative of a constant is just 0. So that's where the 25x to the 24. No? Awesome. Whole class again. Okay, you see here in front of you, one fraction times another, times another, times another, which means if you multiply it all out, you have one large fraction. Can you see that the fraction is in factored form? Yes, or 2 means no. So this big fraction, would you consider that big fraction to have a numerator that is factored yes or 2 no? Show me. Cami says yes, so Cami, what are the factors of the numerator?
The numerator is 1, 2, x to the 5th plus 3, and then 25x.
Nicely done. How many knew that it was factored correctly? So that's 3 points, 4 for Cami. Cami, are there any factors of the numerator which match factors of the denominator?
Yes, 25.
Perfect. So those divide to make 1. So the final answer would be what, Cami?
It would be 2x to the 24. What? And then x to the 25th plus 3.
Nicely done. Follow-up questions from anyone? Please.
So, did you just do like you reduce the 25 on the numerator and the denominator?
The key word is we took a factor of the numerator, 25, and a factor of the denominator, and we divided them to make it. Jackson, which one? 21. Read 21, Jackson.
ln parentheses xy parentheses equals x.
We have a question to there. Someone pick up some extra credit to know what to write on the next line. Simon.
I would just start it off by saying 1 equals, and then b parentheses ln xy over dx.
You've got to find time to change the cable that communicates with my computer because it stops working every once in a while.
How long will it take?
So far, it's coming back fairly quickly, but I worry that someday it won't come back. I've got to find time to fix it. There we go.
Honey.
Oh.
No, stupid board. There it went. Okay. Good so far. Now what do I do? Go Deborah.
So it's going to be 1 over.
1 equals.
Oh, sorry, 1 equals 1 over x, y. And then it's going to be the x, y over
Nice. Perfect. What else? Ellie.
1 equals 1 over x, y multiplied by 0 dx is 1 multiplied by dy.
Okay, I'm going to give Ellie 3 for showing a really good trap. 4 actually. She's always had 4. Okay, we're going to look at what I wrote. That's a common error, but it's not right. It's wrong.
So don't you need to put?
You have to use the product rule. Yeah.
The line in front of
Yeah, she just forgot to use the product rule.
It's all good.
So say it. Go ahead, Sarah. Tell me what you write. You have it.
y dx of this.
The way I remember the plus to minus is addition really is, multiplication is really repeated addition. Subtraction is, division is repeated subtraction. So, yeah.
And then x dy.
Nicely done. Questions from anyone? Please, go.
2 steps up, like, how did you, yeah, so, and then you went to the 1 over xy, how did you get that?
So from here to here, we're using the ln rule. Is that your question?
Yeah.
Good. Anyone else? So at this point, I don't want to write dy dx anymore. It just gets a little bit clumsy. Now we have to do algebra to get y prime alone.
So then you multiply, 1 over xy on both sides.
Perfect. We take both sides of the equation and multiply by xy, reduction in. So we take this side of the equation and also multiply by xy. And pause there. Make sure that makes sense to you what I just did.
Hold on, what did you just do?
Okay, pause. So what I did is I have this equation here.
Yeah.
I'm trying to get the trying to get the y prime alone. What I noticed, Kelsey, is this term over here is kind of all by itself. It's this multiplied by all of this. So if I multiply all of this by xy, I see this times this times this. They're all factors. So this divides with this to make 1. But if I multiply this side by xy, I have to multiply this side by xy. Is that your switch in? Landon?
Yeah, that, yeah.
Jackson, why does the 1 over xy not multiply with the y?
Oh, like by this one?
Yes.
It is. Good question. What I have right here is 1 over xy multiplied by all of this, multiplied by this. They're all being multiplied.
Like what I'm saying is that why is there a parentheses there? Because usually when you use the multiplication rule, there's usually not the parentheses, right?
Oh, I got you. So what happened was when we started, we had this times this. They're being multiplied. Well, one thing's going to become 2 things by the product rule, but whatever these are, they're still multiplied. So this still must multiply by this.
Okay.
Does that make sense? Good. Anybody else? Superb. So these divided to make 1, so now we have a simpler expression or equation. Xy equals y plus xy prime. Somebody else? No, please.
Subtract the y,
Subtract the y.
and then you're divided by xy
Divided by x. On the answer, did they factor the numerator?
yeah.
In Unit 3, we like all of the derivatives to be factored. So I believe on my test, if you can factor, you will. So if you fail to factor, you will fail. Use Marissa Bitterstone. When in doubt, factor it out. So I like mine better. Questions? Please. Sure. 310 for me. Like that? Or is it multiplying constant, so it's not really needed inside of the derivative? I have a constant rule. You see that out? This 4 is a multiplying constant. I can pull the 4 out of the derivative. So I use the constant rule first. I take the derivative of both sides, use the constant rule to pull the 4 out.
So like before, you could have the dy over dx and then everything.
Yeah, everything would be inside.
And then that was okay.
Is that okay?
Yeah.
So then I have this. Log rule. 1 over the something.
Allie Walker, Kathy Romaine, please come to the main office. Allie Walker and Kathy Romaine.
You wait for the kill shots.
Sorry.
6-12. This week, I watched the same Really? You guys are giving. Big week day day. One thing I can see it being interviews for.
Are you just sitting here all day?
Bye.
Bye. Did great today.
What?
Wish me luck.
I said she loves the job.
I don't wish you luck. I hope you get screwed by Garlock. Not screwed, that's it. I hope God destroys you. Bye, Brico.
Divide to make.
He's a guy. I mean, you do get destroyed.
I actually love it.
I hope she eats you.
Did she ever do this last year?
She was in the SBO, not that's true.
Bye. Have a great day.
Bye, Dad. Have a good day. Bye.
Are you grading yours? How?
Just put it on the desk.
Yeah, no, you just want to scan it. I'm not keeping the score. It's a practice test. So it's not the, I'll help you. Hold on.
Yeah.
Did work?
Oh my gosh, I was grading in my class.
No, I didn't like it. So hold on.
Did I do it wrong?
No, it's, I don't know why. It's been kicking out a few forms. I don't know exactly why. 1 second.
Sorry.
Sneaking behind you. You're good.
It was awesome.
If everything's not perfectly flat, it complains.
Oh, got it. Thank you.
It's because it's an optical reader, so if it's bouncing around, you can't read it.
Thank you very much.
Welcome.
Seriously. We put
Parents?
Yeah.
miles on our, like, we drove everywhere, like.
Thank you.
You're welcome.
Last week. Back up to Clearwater.
Okay, I literally said 11:30
Yeah.
and then I realized that I spent lots of time and everything. So now I'm here for like the whole prep period.
Whatever you need.
Okay, yeah.
You're fine.
But so I'm also supposed to do like informational interviews from the profession that you're in. But if you ask you a few questions about teaching as well.
Yes.
Okay.
Now this will seem a little bit implied, I apologize. But I kind of need to change this table, and I can actually do that while I answer your
Yeah,
questions,
that's
so I
totally
don't want to
fine.
be
Yeah.
rude, but.
No, I don't want to take up the time right
No,
now.
I
Yeah.
just, I'm always so short on time.
Yeah, I
I
understand.
spend too much time with students.
Yeah, that's totally fine.
It's not that I spend too much time, I really like spending time with students.
Yeah, yeah.
So, hold on a second, let me just park my brain. Yeah, I'm ready. So, you can just stay here and talk loud and follow me around, which is ever easier for you, Brittany, so.
You guys never come here. Thank you.
You're welcome. The room will get really quiet, so then it's easy. So
Okay,
it's
yeah.
when people are talking.
Yeah. So what made you consider going into teaching in the first place? Like why that job changed?
My advice to everyone is, there's a book I've read twice. This is a little bit of a long answer.
Yeah.
You need to give short answers. You just tell me.
Long answers are awesome.
Okay. There's a book I read it twice. I first read it, my first job was with Exxon, the oil company, and it wasn't a good fit for me. I thought it would be, it just didn't turn out to be a very good fit. And I really struggled to, I tried really hard, but I struggled to really be successful in my job. And after 2 years, they decided it really wasn't a good fit either. So they came to me and they said, well, we have a new job for you, a new assignment. Your new assignment is to find a new job.
Uh-oh.
Which that's not
what they said?
the most, yeah, it's not the most fun thing to hear.
Thank you.
But the good news is, thanks, Sally, the good news is, they said, but we're gonna keep paying you. Like, you will still be on the payroll, we're gonna pay you full salary. And just to give you a feel for it, it was a very good job. When I got my job as an engineer, I was offered $36,000 a year starting salary. At the same time, the starting teaching salary was about $15,000. Very good job. They said, no, we'll keep paying you full salary. You get full benefits, that you're still on the payroll, but your assignment is to find a new job. And we'll even give you our human resource department to help. We'll give you an office in human resources. We'll give you all these books. You have access to our computer system to help you find a job.
Why did they give you all those resources instead of just like, why?
In my opinion, it's because they are a very professional company, and they want people to know we are a professional company. And even when we find that somebody doesn't fit, we don't just cut them loose. We want to help them land on their feet and kind of move on with life. So even though it was not a good fit for me, they were extremely generous. And they said they would do that for 4 months.
Wow.
Or until I found a job. So if I found the job first, they were like, well, then if you find a job, and let us know, we'll take you off the payroll. If not, you have 4 months
Please stand for the Pledge of Allegiance.
So yeah, and I've only been there 2
I
weeks.
pledge allegiance to the flag
So
of
very
the
generous.
United States
Anyway,
of America.
one of the books they gave me has a funny title, but it's a really good book. It's called What Color Is Your Parachute?
Thank
It's been
you.
around for about 50 years. So it's a really old book.
Ukulele Club has been postponed for 2 weeks until Friday, November 11th, due to the football playoffs.
Okay, so it's and the book is all about
Team is selling
trying to
Maple Wine
learn
and hot chocolate for
what it
$1 at
is you would
Logan.
really
So come
enjoy
try
doing
it.
as a career. And the focus on the book is much better than lots of job hunting guides or career guides.
There is a
There's a
Canine
lot of
Club
career
meeting
guides
on
do
Friday
focus
during
on
lunch in room
what you actually want to
305.
be doing.
Everyone is welcome.
They just
and we
say
hope
things
to
like,
see you
well,
there.
this job pays this much.
Yeah.
And if you're an accountant, you keep track of, company's financial records.
Yeah.
Or if you're an engineer, you design things. Well, that doesn't tell you, I'm going to stop the recording.
Your username
That
is
doesn't
your
tell
ID and your
you,
password is your birthday. See Mr. Gibby or the posters in the hall for